A football player or striker, as I've chosen, has to do aerobic exercise to sustain their performance across 90 minutes and lots of jogging for long periods of time. But they also have to do anaerobic, like short, sharp sprints, shooting, passing, tackling. So for the aerobic activity, it will be typically low intensity, high duration, like jogging around the pitch. And the key components of fitness would be cardiovascular endurance, muscular endurance, and body composition. Then for anaerobic, like shooting or short sprints, it would be high intensity, low duration. For anaerobic, the components of fitness used would be muscular strength and flexibility. Uh, the training methods required for aerobic would be continuous because it would help to improve your cardiovascular and your respiratory system. You'll be able to breathe more and pump more blood around your body to your muscles so you can keep going for 90 minutes. And fartlek, because that will also work your aerobic system, like your cardiovascular and your CV system particularly. And it's well suited to football, where you have lots of different aspects of, like, where you'll have to keep going for a while, but you'll do sprinting, jogging, and long distance running. Then for anaerobic, you could also have fartlek because of the sprinting aspect, but you'd have circuit and weight and interval training. And for anaerobic, you'd use training methods like circuit training, weight training, and interval training because it would help to increase your pace and your short-term bursts. So for like shooting and short sprints, and it would help to improve your systems like neuromuscular system, your energy system, and your skeletal system. For aerobic, the fit would be so frequency 3 or 4 times a week, intensity sub-maximal intensity because it's over a long duration, and you're jogging, and it would be 60 to 70% of maximum heart rate would be ideal. Type would be aerobic because you're jogging for a long time. Long time. Time is I would advise 30 to 60 minute sessions, and maybe increase the sessions by 10 minutes each time. For example, you could jog from goal line to goal line on a football pitch repeatedly about 5 times, and each time you get to the end, do 1-2 passes with a partner just to keep that football aspect in it. And for anaerobic training, you do this 5 times a week because it's shorter. It's not going to be as tiring. And it's at maximal intensity. You do short, sharp, maximal bursts like sprinting or shooting. Type would be anaerobic, but aerobic for recovery, so that it can get energy to stick the P back on in ATP to give you more energy. And then time would be short, like 10 to 15 second sprints with a 2 minute break over and over again. CV system adaptations for aerobic training. The top right image shows how training causes your stroke volume to go up. A highly trained athlete will have about 20 mil higher stroke volume at rest than an untrained athlete, and at max, highly trained athletes will have a much larger stroke volume than at rest. This is because of cardiac hypertrophy, which makes your heart stronger, which means it can pump more blood out with less force, so therefore your stroke volume goes up. And then resting heart rate decreases, which means which is better, because that means you're fitter, because it means that because you need less heartbeats to supply more blood to the muscles. Furthermore, the bottom right image is showing stroke volume pre and post training. So as you can see, in post training it's a lot it's a lot higher, which shows obviously you can pump out more blood after training because your heart is stronger because of cardiac hypertrophy. The middle image is showing heart rate post-training and pre-training. The graph shows heart rate is lower post-training because you need less heartbeats to pump out more blood because your heart is stronger. An athlete's heart is where athletes have larger hearts because their hearts will work much more and therefore they become much larger, as a heart is a muscle, so the more it is worked the larger it gets, just like your bicep would. If heart size increases, then particularly the chambers will increase, which means that the athlete can keep working at the same intensity for longer, so their performance won't drop. The bottom left image shows heart rate in exercise and in recovery. As you can see, in exercise, post-training and pre-training is similar, but post-training is just a bit lower, and then post-training it drops significantly more after exercise. This is because someone who's been trained will have a much lower resting heart rate. Cardiac hypertrophy is the enlargement or thickening of the heart muscle because of the increase in size of different parts of the heart, like the ventricles. This because hypertrophy basically is an increase in muscle size from more training with more resistance. So the heart is a muscle, therefore it's going to get bigger. Resting heart rate range will get larger because resting heart rate will decrease and maximal heart rate always stays the same, 220 minus age. So therefore you'll have a larger heart rate range, which means a better performance because you can work harder for longer and your heart can pump out more blood for less beats. VO2 max is much higher post-training than pre-training, as you can see in the bottom right image, which means that basically you can breathe in a lot more oxygen, which means that you can get more oxygen to work in muscles to replenish them, which means you can work at the same intensity for longer and therefore performance will improve. VO2 max increasing means that stroke volume increases, which results in your maximal cardiac output going up considerably. So as you can see in the top right image, post-training your cardiac output is a lot higher than pre-training, which shows that you can breathe, your heart can let out more blood to your muscles, which can work for longer, keeping at the same intensity for longer, so performance will improve. The increased size of the left ventricle cardiac hypertrophy also lowers systolic blood pressure, as there's less arterial pressure but needed to pump more volume of blood out of the aorta or through the aorta, which increases cardiac output. Training can cause an increase in parasympathetic activity of the heart, which means that there's less SA node firing rate, which slows resting heart rate. How is blood affected? Long-term exercise can lead to the development of a capillary network, which means there's an improved capillarization, more oxygen diffusion and more CO2 removed, which means that your muscles can work for longer because they get more oxygen to them. Increase in performance. Exercise increases the red blood cells within the body, and so for example a sportsman like my striker will have a lot more red blood cells, which means that you can get more oxygen to work in muscles and exercise, so you can perform at the same intensity for longer. Trained males, like an athlete, blood volume was 75 kilograms per mil of body weight, whereas women it's 65 kilograms per mil. Exercise and training increases the proteins in your blood plasma, which means you can have more water retention and it increases blood volume. Aerobic training will decrease your plasma viscosity, so the thickness in your blood, which means it can flow through easily, get to your muscles more easy, giving them oxygen, so your performance will increase because your muscles can work at the same intensity for longer. How is health affected? Coronary heart disease, CHD, is a disease where a waxy substance called plaque builds up inside the coronary arteries. These arteries give oxygen-rich blood to the heart. Aerobic exercise will help make your heart and blood circulatory system quicker, more efficient, which will drop your cholesterol level and keep you healthy and reduces the chance of CHD. Atherosclerosis is a disease where plaque builds up inside your arteries, and regular aerobic exercise will reduce fat in blood and lower blood pressure and cholesterol, reducing the risk. Atherosclerosis is also the narrowing of artery walls, whereas arteriosclerosis is the stiffening or hardening of the artery walls. Hypertension is overly high blood pressure, and regular aerobic exercise reduces blood pressure of the heart as the heart gets stronger, so it can pump more blood with less effort. Neuromuscular system. Neuromuscular system adaptations, aerobic. SO fibers or slow oxidative fibers will get stronger and get bigger, which means that they can send out stronger impulses so that your muscle contraction will be larger and recruitment of these fibers is increased. Therefore, your performance will increase because your muscles can work harder and produce more. There are also more mitochondria, which means there is a bigger oxidative capacity because of the increase in the mitochondria in the muscle cells. Your performance will get better because the muscles can get more oxygen, therefore they can work for longer and you can work at the same intensity for longer. Neuromuscular system anaerobic. Hyperplasia is the action of splitting muscle cells, which aids muscle growth. Research into hyperplasia continues, but it's still quite controversial, and there's not much evidence to show that it is a recognised adaptation. This will help my striker's performance because muscles will grow, meaning his contractions will be larger. Weight training can help contractions get stronger, and stuff like sprinting. Men do develop muscles faster and render higher or produce higher maximum output than women, but women do recover faster and their muscles are more fatigue resistant. Tendon strength. As skeletal muscle gets stronger, larger, the connective tendons will adapt to match the high demands to avoid injury, which means that our muscles can train harder so we can become stronger as our muscles are growing. Therefore, my striker can train and perform at a high intensity without getting injured. Muscles strengthen, so therefore there's more motor units, which means they're a larger force, and training will help to increase this because there's more recruitment of muscle fibers, which makes a larger motor unit. This will make my striker more powerful and be able to do short, sharp exercise like shooting and sprints faster. FOG fibers. The ability of a motor unit to summate, which means fire a lot of impulses into a target muscle at once, is improved with strength and power training because they need maximum activation of target muscles to create the force needed. This will improve my striker's performance because he'll have bigger muscle contractions and he'll fatigue less easily, so intensity will be higher for longer.